Bon dia a tothom. Buenos dias. Hi everybody, good morning, and welcome to this masterclass organized by CIDAI and led by SAP. My name is Joan Moragon. I am part of an innovation team supporting SAP customers in Spain, and I will be moderating this session today. But let me start by providing a little context how SAP got here. As you all know, CIDAI's mission is to demonstrate the power of artificial intelligence and accelerate its adoption. Well, from our side, our mission is to make the world run better in order to improve people's lives. And here it is where we see that artificial intelligence, if used well, will play a major role. But now, who are the experts and what's this masterclass about? Well, let me introduce you to the three SAP colleagues that I'm lucky to have with me today. Hernan, AI and Machine Learning Solution Advisor. Stojan, Machine Learning Engineer, and Andreas, Data Scientist. They will be talking first about AI democratization, or how artificial intelligence can be leveraged by our customers without having to be a super expert coder. And then they will be talking about how artificial intelligence can be used to predict quality issues in manufacturing processes. Well, with this, let me remind you that you can ask questions on the Q&A panel at any time, and I will try to pass them on to the experts and will try to answer them all during the session. At the end of the masterclass, if you get to the end of the session, a survey will come up, so please try to answer it in order to improve this masterclass format. So Stojan, floor is yours.
Thank you very much. Hi, good morning everyone from my side. Welcome to today's masterclass. As Juan was saying, this is about, we'll cover two topics. One will be about the democratization of AI, and the second will be a concrete use case we have implemented with our customers on the topic of predictive quality and in the manufacturing field. But first, before we get into these topics, I would like to actually ask you a question about if you know who that is. Many of you are probably recognizing the Red Queen from Alice in Wonderland. And why we selected to have her here as our starting slide is because we wanted to tell you a little story about it. I don't know if you remember the story when you read the book or watched the movie, but at some point in the whole story of Alice in Wonderland, when she falls through this looking glass, she meets the Red Queen. And if you remember, when the first thing which the Red Queen tells her was, right, welcome, down here, everyone has to run as fast as they can just to stay on the same spot. And I'll just repeat it one more time because it's such a cool quote. Down here, everyone has to run as fast as they can just to stay on the same spot. So it's a metaphor actually, and what I wanted to cover here, and I find very interesting, is that it can relate very well to nowadays and what we see in many of our customers, right? They're running actually as fast as they can. They're giving, the best what they have, like cutting costs, cutting time to market, trying to optimize pricing and margins and stuff. But since all around them are doing the same thing, they're still staying at the same spot. And that's exactly, I find it funny that it resonates very well with the Red Queen, right? So I guess the biggest question here is, and I hope that we can get to this point at some point, is how basically we can cut through or actually break the effect of the Red Queen. How can companies actually differentiate from their competition? How they can set off from everybody else and have something which the others don't have? And that's exactly the two topics we have introduced to you today, and we have planned to talk about. One is how to enable everybody to gain from this AI revolution. How can citizen data scientists or people who actually don't have enough background still profit and bring their knowledge maybe or know-how which comes from the business know-how and how they can augment it with AI tools. And in the second part, we'll discuss the predictive quality, as we mentioned, and how this can be automated, having an optimal production, which again will eventually bring a competitive edge for the companies. And with that, I'll hand it over to Hernan, who will cover the first part of the session. Thank you. Hernan, to you.
Thank you, Stoyan. Thank you very much. Yes, I will be talking to you a bit about what is democratization of AI and what is SAP doing for that. But before that, I want to give a very short introduction to what are we talking about when we say AI, so artificial intelligence. And this is very connected with what we call the terms data science, machine learning, deep learning, all are different terms. And what do they mean? What is the difference between them? So let's start with data science. The goal of data science is how to get insight from the data. It's not just to apply science, it's how to get value out of the data. How can you apply different technologies for that in order to get value in terms that can help into the business process that we are having? And there are different areas, several areas that are involved depending on the problem or what we are addressing. So we have from computer science, signal processing, machine learning is one of them. Also mathematics, statistical, operational research, and you name it, several ones. So if this is data science, what is artificial intelligence? Well, artificial intelligence is one of the key topics in data science. So because when we say artificial intelligence, actually we are talking about how can we program machines, how can we run algorithms to show some kind of intelligence, to do some kind of job that otherwise we have to do it, and that they know to take some decisions based on that or what they are doing. So simple ways in robotics, it's very common. So you need to program this to do some stuff. And of course, one part of artificial intelligence is what is called machine learning. What is the difference between artificial intelligence and machine learning? Well, machine learning is a subset of algorithms that they are not actually programmed, explicitly programmed to run some tasks, but they learn from the data. The machine learns alone how to take some decisions, how to discover some patterns. So machine learning is a process to analyze the data and to extract patterns that then and learn from those patterns in order to do, for example, predictions, in order to identify patterns that are not seen just by screening the data in normal way. So machine learning is the discipline where machines learns from the data. And then we have another terms that we hear every now and then, that is called deep learning. And deep learning is actually also a subset of machine learning algorithms that are using neural networks to learn. So if we see all of them together in a picture, we could say that deep learning is a part of machine learning, which is a part of artificial intelligence, and data science is using artificial intelligence along with technology and along with the business knowledge in order to extract value or insights from the data. So with that being said, so when and where is artificial intelligence or machine learning being used in the business today. So SAP is a company that has we are at different industries. We are helping customers in different lines of business, in different industries, in different areas. So we see just a few examples. So when we talk about sales and marketing, everything about churning, about price optimizations, about cannibalization detection, about campaign optimization or product recommendations. There are different use cases in this area that are all using machine learning. Also in the operations, you have a lot of machines in the manufacturing process or in production, and then you want to maintain those assets. So you want to do predictive maintenance, know when they are going to fail, or what will be the quality of what we are producing. So how could we predict the quality? Or if we are talking about for example, utilities, the electricity, what will be the demand, the load, in order to estimate how much we need to produce, for example, in the generators. Also, in the topic of inventory management, or we need to predict the demand, to forecast the demand in order to know how much we need to produce. So there are tons of use cases in the operations areas. Also, when we are talking about fraud and risk, so we want to predict when there is a risk that something will fail, or something will be, or there will be a fraud, or even if for example we are having different risks today, even in the economy, even in for example, the pandemics, are all those risks, how these are affecting my business. So how can we quantify those risks? So how can we do a quantitative analysis having these all random risks, let's say, that you never know when they will happen, but there is some kind of a statistics behind. So also in the fraud management, to identify fraud that in our business. So those fraud and risk are topics that you can see very often in banking or in insurances, that they are using a lot of machine learning algorithms, and also of course in public sector, in criminology as well. So and finally, but last but not least, finance and HR is very common as well. So how to forecast the cash flow, so how to simulate the budgeting. So how we need to know how budget we need, or we need to save for the next few months, for the next year. So what is the profitability and the analysis of the margin, and of course financial risk we already mentioned as well. And in the part of HR, we need to know if our talents are remaining with us, or they are leaving. What is happening there? What is the likelihood of an employee to leave our company? So these are just examples of different areas where we see machine learning and AI. So, but where do we start? When we have a problem, so how do we start using machine learning? So the first thing we need to know is, what is the business question we need to answer? What are we looking for? Once we know what we are looking for, we can decide what algorithms or what kind of predictive technique we want to use. So, for example, if you want to predict whether a customer or an employee will churn, so most likely this will be a classification problem. So it will say you need to classify whether it will churn or not. Or if you think about in a failure of a machine, whether the machine will fail or not, or a product is a good quality or a bad quality, or basically this is a classification. You can have a binary or multi-class classifications, but you have very defined outcomes. Then you have a regression. A regression is when you want to predict a value, right? For example, revenue or number of journals in the next week or month, or how long this machine will work without any failure, how many weeks or months, or how much should be the optimal price for this particular material or product. So this is regression. Then we have another kind of algorithm that is for segmentations or clustering, that the goal here is to find similar patterns, similar behavior in a group of entities. It can be customers, in a group of products, in a group of activities. So how can we find those that are very similar? How can we cluster and separate those? Because maybe on each of them we need to treat in a different way. It's very common this when we analyze a population. So all the people that are at certain range of age behaves in a different way than others that are younger or older, or depending on the, of course, on the kind of education they have or on the kind of culture they live, they have different behaviors. So all these kind of questions comes into the segmentation and clustering area. Then we have the forecasting also, that is adding the time dimension here. So what if we want to forecast, for example, revenue, or to forecast demand across the next year, in the next month, on a monthly basis or on a weekly basis? If we need to plan production, or plan sales, or plan what do I need to have in the warehouse or in my shop, you need to take into account what is the expecting sales. And here, when we add the time dimension, this means that this is not something that you can predict at any time in the year. You need to think into account also the cycles. So it's not the same the different seasons. So you won't sell so many swimming equipment in winter, and you will not sell so much ski sports or snow sports in summer. So this when we talk about time series, we are taking into account also the seasonality effect or the cyclic effect. This is just an example. Another kind of algorithm are the social networks analysis, or the link analysis, where we want to see how different entities interact between them. So, for example, people in the social network, this is very common if you see in all our social networks software, right? So they are doing all this in order to identify communities. Who are the influencers? So this is very common now. So you cannot survive now if you don't post in Instagram, for instance, but you need to be an influencer. So because based on that, you will reach out more people, and this is crucial in marketing. And very close to that is what is recommendation or associations engines, where we, based on what the other people are doing, what is the best recommendation? So this is very common if you see Amazon, for example. You get recommendation on stuff that maybe you didn't think about that, but behind the scenes, you have artificial intelligence that goes find other people behaving similar like you, what they are buying, what they are not buying, what people buy similar to you together when they buy similar stuff like you. So all this helps to do recommendation. This is what it called basket analysis as well. So all these are examples of that. But as we said, the first step before all this is to identify what is the business question you want to ask? And this is crucial here. We cannot start a machine learning exercise, or get a machine learning model if we don't have a business question that we need to answer. It's not just for getting fun. So of course you can do it, but if you want to be relevant, you need to answer a question. You need to have the business question behind. What is the value? What do you want to answer that is valuable for the organization? And then once you have the question, you think how you are going to answer that question. And this, you can choose any of those algorithms that we mentioned in the previous slide, among others. So these are the most common ones. And then once you have what algorithms or what kind of analysis you want to do, you need to start think about data. We will come back to data in a moment, because let's now take one example, and we will focus now in what is a classification algorithms. And the business question that it will be an example that we are going to use this in this part. It will be about predicting an employee leaving our company, or we call it's called employee attrition or flight risk, right? It's more flight risk. What is the risk of an employee leaving our company? And for that, we will use classification. So let's have a closer look at what classification is. In classifications, we collect all the historical data, and then what we want to see is, for example, based on the historical data of employees that stayed with us or employees that left the company, we want to machine to learn what were the conditions that make those employees leave the company or stay. And in the end, we want to automatically identify those. Imagine here we have two conditions in this small chart, and you can see that automatically the machine will identify what is how to separate both situations. So those that are leaving and those that are staying. And of course, you might have some exceptions. So people that you don't expect to leave and they are leaving, and people that you expect to leave and they are actually staying. This is also comes to do with the accuracy of the algorithms. Of course, you can never know 100%, and there are always infinite variables if you want to have the ideal model. But you can have a very good accuracy to predict, I don't know, 95% of the cases, for example, with existing data. And if your accuracy is not enough, this means that there are additional factors that you are not taking into account, and then you need to add additional data. So we need to work this. This is an iterative process until you have all the data. So when we are talking about data, we have different kind of data. We have data that can be ordinal, like a level 1, 2, 3, for example. We can have a continuous data, like, for example, age or salary or things like that. Or we have nominal data, that means data that is good, bad, or, for example, also the name of the section where I am working. So, for example, I'm working in IT, in sales, in development, etc. So this can be a variable, a nominal variable. And of course, the output should be either it should be nominal, either binary in this case, whether it will be yes or no, or 0, 1. So this means 1 or yes will leave the company, 0 will not leave the company. And then we need to analyze the performance, as I said. So what is the accuracy? What is the robustness? Well, robustness means, okay, this is a very nice model, but what happens if I apply to new data? Will it still perform good? How general is this model? So all this comes with the analysis of the model performance. So we are going to use this, as I said, it can be used in different areas, in different examples, and to address different business questions. In this case, we are going to focus on the second question here: which employees are likely to resign? So this comes from a real project that we did with the customer from us. Of course, they have at that time they have limited visibility on how satisfied were the employee. They have this. They were not able to understand why the people were leaving their jobs, and they wanted to know what are the main KPIs impacting or making an employee leave the company, because they want to take actions on that. It's not just I need to know what is which employee is leaving. I need to know why he's leaving. I need to know what can I do to prevent this to happen. So of course, for that we need to combine data from different sources. In this case, we have a solution that is called Success Factors that have a lot of all the employee data, but we have also additional data outside that, and we need to combine all these different data sources and to merge that and to extract some value out, combine in a way that we can create a machine learning out of it. Then we need to enrich that data once we have it. For example, we could add the distance from the employee to my place of work, so to the office, and this is a distance that is different, but is impacting. If I want to know if an employee is leaving the company, most likely if I live next to the company, I will stay because it's comfortable. But if I have to drive, I don't know, 50 kilometers, or I have 1 hour to get to the office, most likely this is an impacting factor. So once we have that, we apply machine learning. We put that results in a production, so that means that this result can be used by the business people. And we created some dashboards and visualization there. So that allowed the company to monitor the key KPIs, understand what are the conditions that are making an employee to leave, and then to try to take actions. Of course, if there is an employee that they do not want, of course they will let him go. But if they want to stay, they need to know what they need to do to make him stay. And of course, to perform simulations on that, right? So, okay, what happened if I don't know, I increase the salary? Of course, that's a good one. Sometimes it's not always possible, but you can give other benefits, either other trainings, other things that can make you more happy at the job. So this was a complex exercise we did. I am going to show you a little subset here. Of course, I cannot show you exactly this data because this is very confidential, especially when we are talking about HR. But I will show you how we enable them to do this kind of analysis. And I will focus especially on the part how we enable business to run these models. Later, with my colleagues Stoyan and Andreas, you will see more how to run machine learning using Python and R from a data scientist perspective. But now I will focus now how can we make these business people run this. So in general, when we want to start with this, the challenge is on one side, the data is in different places, different silos, and you will see this in all the companies. You will have data in one system, in another system, in one cloud, on-premise, in a data lake, in the ERP system. So how do we merge all this together? Then, of course, you have different people. You have you have data scientists that need to use this data, but you have also business users, you have IT people, you have business analysts that want to run some reports. So how can we enable this data to be consumed by all these different profiles? And then we have the technology part, because all this need to be supported by a technology to do it in a fast way. Of course, I can have the request from someone that needs some data, and I can do an extract and start the project to get the data. But what happens is that, no, I need also this data source. So we need a technology that can support all this in an agile way. So this is the main concept of SAP. When you hear SAP, you always usually hear about our solutions, our applications from the ERP perspective, or the solutions that we have for the different LOBs. This is what we have here in the middle, right? So these generic solutions that we have for all the industries. We have also some specific industry solutions, for example, in the digital supply chain area for during the manufacturing process or in production, or the human resource solutions as well. So there are different ones, but all of them are supported what we call the business technology platform. And the business technology platform is the place where we not only build our solutions, but it also allows ourselves to create anyone to use those capabilities to extend those solutions, to add additional value, and to create our own extensions or custom applications. So the business technology platform, we can say, it has several parts, and is a comprehensive group of services that we can divide in 5 groups. On one side, tools for develop applications, and here we have from complex applications that a developer will do up to low code or no code applications, where you can quickly do an applications without having to code a lot or to know JavaScript and different languages in order to do it. Then we have automation technologies there. So how can we automate processes that are repetitive, processes that workflows? For example, whenever you want to change something, you need to get approval from here, from there. How do you automate the process? Then another part is, how do you integrate the different with the different data, or with the different systems, and with the different process that you are doing? How do you integrate all together? And then, of course, you have the data management. How do you move the data from here to here? How can access the data? How can you enable users, depending on their profile, to access this or that data? And how could you perform analytics on top of that? And of course, the artificial intelligence. How do you add intelligence to those processes, to all the others? So, given that said, we are going to use, or what I am going to show is a very simple architecture for this use case. That is, on one side is what we call data warehouse. That is where we are going to have the data and to merge the different data sources together. There also we have what we call the multimodal engine, here the in-memory database, where we don't only have the data, but we can also apply machine learning there without having to move the data out. And then we have on top the analytics that we want to do on top of this data. And there is also the part of orchestration and deployment that I will not mention in this part, but my colleagues will mention later in the next use case. So let's come again. The goal is to predict employee attrition. The first part we need to do is data preparation. So as I said, data preparations, we are talking about this area. We are focusing on the data warehouse. How can we merge this data? How can a business analyst can start playing with the data? And we have here different things to take into account. We need to take into account, on one side, the connectivity to the data. We need to be in a space and know who has access to the data. This is what we call a space. And we have also the part of the data layer, so where we can create, merge all this data together, and also what data do we want to share with the real business and business users that want to access. They are not care about how the data is combined, but maybe they care about just a table, just some entities that they need to access. So all this can be used by a citizen data scientist, we call, or a business analyst. Of course, we have more additional stuff, like you can, we have out of the box a catalog of business that we can, business models that we can bring here, and as well as data marketplace that we can consume and buy some data. But let's leave this out for the moment. So we are focusing on that. So let me come now to the application that we are going to use, that is called Sap Data Warehouse Cloud. And here I am going to show you how are we using to consume that data. So first of all, we need to identify which is the space we are going to use. So we can have several spaces here. We are going to use here this BTP for success factors, because this is a lot about success factor data. And here in this space, we can define what kind of, what size do we need, which are the users that have access, what are at the database level, where are the different schemas or data that we are going to use, and what are the connections of this space, to which systems is connected. In this case, it is connected to 3 external systems. One is the a database, and the other is the success factors. Once we have that, we can start playing with that. And we can create tables. For example, we can have here, as you see here, we can have remote tables or local tables. So remote tables, we can access a system. For example, we are accessing here a person table in the success factors. And the interesting part here is that this, you can set whether you want to replicate or you want to real-time access, live access. Then you have the views. On the views, you can start combining all these data sources to do to get in a certain way. For example, in this case, we are combining the data per person with per personal with per address. So all these are different data that is coming from success factors that are providing different information. Per person is the the personal data, not the private, sorry. We keep only one part of this we are using here, but we have also information on that are kept in the system in per personal, and also the address in a different table. And also we have here data that is coming from another system, that is the country codes. So all this together make a view that is called view person info. Good. Once we have, of course, with that, it's not only combining. We can create aggregations. We can create additional columns, calculate additional values based on the different data. We can filter the data. So there are different actions that we can do in a view. And of course, apart from the view that you can do there, you can still do scripting views. For example, if someone knows SQL, can do the same with SQL. This is another example of a view. Do it with the query, with SQL query. So both options are available depending on the preference. Then another thing that we have is what we call data flows. Data flows are flows that you want to run to perform some actions. For example, in this case, I am doing getting the data from SuccessFactor in my local. I am replicating the data in my local table. But I want to do it. I don't want to bring only all the data every time I look for it. I want only to bring the delta, what changed only, because otherwise I need to bring a lot. And this is what we are looking, going into delta and get it. And I can run this. I can run this at any time, but I can also schedule it. So I have the option to schedule and to say, for example, every night, give me all the updates of the day, for example, or every week, or even every hour, or whatever I need. So I can run this. Once I have that, I can go also in what is called the data builder, the business builder. Before it was about converting the data, but then I can create a model on top of that that can make an abstraction of the data model behind, so all the business only see the final one. And what is the value of that? Why do we need to have this business? Or what is the advantage? The advantage is if for some reason I have to change the data behind, the business doesn't care if I get the data from this system or from the other system, or I get additional data and I want to include that. This will be completely abstracted from that, and I can do it at the data builder. I can add additional data, and this will not affect the business at all. So, given that said, let's go to the repository, and here I have, for example, my list of data. I will go for what is called a full view, combining different data sources, and I want to show you how the lineage analysis is done, because this is also important. You want to know, okay, this is complex. You start merging data. How do I know in the end where is the data coming from? So I can get a view and I can see where is the data is coming from, and you can see here it is coming from different entities. You can visualize here in a different ways, and I can go also from the bottom and see how every data is affecting different parts of the view. So with that being said, this is a way you can enable business user to start merging the data and to prepare the data before doing any machine learning. And actually, normally 80% of the time for doing any machine learning or predictive analysis is the data. So with that given said, I will move to the next. Let's now go to the just a second. Let's go now to do some machine learning models. So when we are talking about machine learning, now I will go to talk about analytics, but we are still using the machine learning that is within the platform where we have the models. Why I mentioned that is because in that platform we have several libraries for machine learning. We are not talk about all of them now, but if we talk specific about predictive, we have one particular one that is automated predictive library, and this is the library that we are going to use here. And this is prepared for citizen data scientists that want to use machine learning, but they do not want to code, or they are not actually data scientists that can know all the details of the different algorithms that they exist. So how do they do it? So let me go now and show you one example. So this is a tool that is called SAP Analytics Cloud. And here we have, for example, we got the data of employee attrition. We can open the data. We can also, of course, connect to other data. We can even bring data from Excel, or we can connect to our system in this case. And then we can take a look to all the data. We have several columns, and what we want to predict is flight risk, what we have at the left. Then we can now create what we call a story, and this is a story that we want to analyze. And here we can go into the data and we can start playing with the data. Let's say we want to get some insights, right? So this is the first part of the data science. We start to play to visualize the data, observe, for example, the salary. I want to see the salary across for example, different performance analysis from people, or I can see that at different departments. And once I can do that, I can collect all these different charts, and we can put it in a place where we can we can modify the chart, of course, but we can also put it in the page in a page where we can visualize several one of them. But then what we want to go is to what is called a smart discovery. Smart discovery is the part where we want to do machine learning. And the goal here is to select what we want to predict. In this case, is flight risk. And one means that this employee left the company. And then we want to see for each employee, I want to see what is why is he leaving? What is the factors that makes him leave the company? I can decide what information I want to take here, and then I will run this analysis and will automatically create a machine learning model connecting all the data and finding the relationship between all the different parameters. And I can see here some KPIs here, some charts on that. How is the distribution? And we see that there are different variables that are affecting here in a different way. So for example, time in the previous position. And here I can see, for example, the key influencers. So we see that this is what it tells me here is that this is not just one variable that is making an employee leave. It's a combination of all of them, each of them having a small contribution, right? So for instance, age, salary, country, performance, etc. And I can start also even I get some reports to start playing with the data and see how all these factors are connected in which way with all of them. So for example, and also the interrelationship between them. So for example, the salary and also the promotion within the last year. So how all these together are affecting that, right? So we see that there are some people that are at certain ranges, depending on the promotion, if there were or not a promotion, the likelihood is completely different for them for leaving the company. So this is just an example of what a business analyst can do. Another thing that we can do is also what we call a smart predict. Smart predict is the ability, okay, I know a little bit more of, I am not just a data scientist, a business analyst, I understand what is happening. I want to deep dive in the model a bit more. So what I can do what is called predictive scenarios. And here I want to create my own classification model. And I want to understand more what model is created and what is the result. So I can create my model from scratch, for example, and then save it. This will be my model. And when I have this model, the first thing I have to do is similar to the previous one, is choose what is the data source that I will use. I will use exactly the same as before, the same data source, this employee attrition new. Of course, the target, again, flight risk. And then I need to see which values, which columns I want to exclude here. It's similar to the previous one, right? For example, employee ID is not something that is connected. And I train the model. And this is training several models and keeping the best one out of them. So it's not just one model. It gets the best of all the different models, combining the variables in different ways. Also doing the pre-processing of the variables. So all these actions that normally data scientists do in Python, doing the data preparation, this is done automatically here. And I get here the best model. It tells me how the accuracy with the predictive power. I also get the contributions from the different variables, and I have KPIs here that I can use. Of course, I have also the more details on the influencers. For example, how much is each variable influencing and how it is influencing. For example, if I see the age, I can see here which ages are positive or negative influencing the churn, as well as for example, the region. So, and then we can play with what is called a confusion matrix to see, okay, what happens if I try to keep more of these people, right? And I can do a profit of simulation, so I can assign values to those. What happens if I detect in advance and I do things? What to keep that person? How much it costs to keep or to release? And I can, of course, see several performance curves. Good. With that in mind, what we can do is also let me go to another. What we can do is also apply this to new data. And the good part here is you can apply it to data, to additional data. You can specify exactly what data do you want to get, what results you want, and you can apply this model to any data. So for example, if you have the model, you can apply this on a monthly basis to get if there is any change in the customer, in the employee's behavior. So I will stop here because in the interest of time, I want to thank you very much. And with that, I will leave now for my colleague Stoyan to continue. In the meantime, if there is any question, please feel free to ask.
Thank you, Hernan. Thank you for your time. So while we are switching screens, I did get a question for you. So one of the parts of your demo was about getting data from multiple sources and then preparing that data in order to then apply machine learning, for example. And you said a pretty interesting fact, like 80% of the time is used just to prepare the data even before you can apply any intelligence there. So this tool that you were using to model the data, once you model that data and prepare that data, which it seems to be a very difficult part, can you leverage another algorithms outside, or can you leverage this data that it's already modeled outside SAP?
Exactly. Good, very good question. Yes, the good part here is that with this, what we are presenting here is a way to combine the data, and this can be consumed within SAP solutions, as I showed, but also externally. And actually, the good part of creating this model within SAP in Data Warehouse Cloud, for example, is that you are keeping the semantic, you are keeping the key, the metadata of the data. So you don't need to worry where is the data coming from. It is getting updated automatically, and you keep the semantics. So this simplifies a lot when you want to use it outside. For example, if you want to consume from any machine learning environment, you can connect to that, and you can get the data in the proper way already. So you are saving a lot of time there as well. Yep. Thanks for the question.
So if there's no more questions, maybe we can continue.
We cannot see your, we see your desktop, not the presentation.
Oh, okay, 1 second.
Oh, we see the presentation open, but not
I got you. Yep, sorry about that. Thanks. So now we are switching gears a little bit and going into another direction. As we promised, we'll go into the predictive quality case. Andreas and I will be taking you here and talking about how quality can be predicted, to what extent, what it means, and actually what we can do about it to actually gain business value out of it, right? Before we start there, maybe just we can take 1 or 2 steps back to start talking, maybe take a glimpse into why is this relevant, right? And because we have actually various audience here with different profiles. So just to make it clear that during production, pretty much all over the place across all industries, from chemical, actually high-tech, discrete industries, machinery, automotive, everything, right? Deviations in the end quality of the end products occur very, very often. And well, if you're lucky, not so often or not so big, but they're there. And that lies a little bit in the nature of the whole production processes, right? So production processes are normally a multi-step process, which depends on a lot of factors, from, you know, obviously the raw materials you're using, from the settings and the expertise your shop floor personnel has, going through environmental factors. Think about some raw material which has to travel, I don't know, through extreme weather conditions. It will be different when it's winter than when it's summer, depending on what it is. Or thinking about things you cannot control. Think about your raw supplier of the raw material. They might change something in their production. Suddenly they start delivering something which have variations. So you, in the worst case, like find out about it pretty late in the production, which brings a lot of issues for you and for your company. There's also changes in recipe. There's actually, this is an endless list, and as you can see, it's the combination of those which makes it very, very difficult to control it and really control it end to end. That's why there's always some thresholds. There's always some like limits which are allowed for the quality to vary. But oftentimes, as I said, it goes outside of these limits, and that's the topic we're talking about today. Why is it critical? I think it's everybody knows, obviously, financial risks. You know, there's many things here. Not only, you know, that you will not be able to cover the demand, and you probably will not be able to cover the KPIs and the agreements you have with your customers, to right. It's also about the work you have to do, right? Think about, I don't know, you start producing a part which is a multi-part process. You get some plastic part, and then you have to form it. And then it goes, I don't know, 10 other steps, and then it gets built into a car. So imagine you find out about the low quality after step 3, so you have to either scrap it or maybe in some way remelt it and redo it again. So this is a lot of rework involved. So all of this is, of course, connected to a lot of financial risks. There's the reputation, of course. You know, imagine you have some products which are out there with the consumers, and then with nowadays anyway, even worse than ever before, there's social media, there's internet, so very, very easily you can ruin your reputation. Another thing which is often forgot, you see here in the last point, is the safety risks, because oftentimes the parts you actually create might be part of a bigger machine. Think about a train where your brakes, and you're delivering the brakes, and the brakes don't work. So there's a lot of liability problems here as well, which again brings a lot of risk. So I think we will agree that it's very, very relevant and important part, the quality of our products. That's why it's no surprise that pretty much all of the companies we have seen and customers we have seen want to find ways to kind of deduct or decide on the expected quality well in advance, ideally, right? So that the proper action can be triggered. What does it mean? It means that it's not enough help to know, okay, this is a product of bad quality. Sometimes it is, but most of the cases, the most value you can get out of it is if you know well in advance that the quality will be changed in terms of decreasing, right? Because this gives you time, for example, to adapt your process, to take the other supplier and actually react, right? It's just to take preventive actions and not just like after it happens. And there's two main approaches. There is actually more, but let's look at the two main ones, right? The traditional ones we have seen is related to these quality checks, right? This is traditional, pretty much every manufacturing company has it in place. This goes, sometimes you go into a random process. After a piece is produced, you take it and then you bring it to a laboratory, go to a few lab tests to decide on the quality, or sometimes you have a more systematic approach. But what we've seen, I can think of a producer of wood, like wood parts we have worked with. So they had this kind of quality checks in place, but the process, like this, the whole process of performing this check took quite a lot of time. So they actually were interested in how these parts react in underwater. So they had to put them in water, wait for 24 hours or even more. Then they would be able to see what is the outcome or if this is a good quality or not, using some random samples from the production. As you can see, this 24 hours, or sometimes it's even 1 week or even longer, depending on the process, is a lot of time. So what do you do with the production during this time? Do you keep producing and then wait for the quality checks, and then you, I don't know, re-scrap or you work the stuff or throw it away? Or how do you do it? So you see it has its disadvantages. And then the other way is the data and AI driven, where you try to obviously predict it in advance based on some data model, based on historical cases where this has happened in the past, right? And so the disadvantage of this, if we talk about disadvantage, is definitely the part that this know-how to do this is still missing. And we've seen a way how you can democratize AI in some cases, but a general rule of thumb is that most of this know-how is missing. So what is this AI-driven quality in manufacturing, right? So the main idea, obviously, is predict the possibility for future drops of the quality, and so that it gives you a time to have a preventive measure to counteract this trend. But beyond that, right? Sometimes people forget that there's actually more behind that than just the prediction, right? Because when you predict it, as Hernan was mentioning also before, predicting attrition of employees, you want to understand why they're leaving or why your quality is going down, because this allows you to do this root cause analysis. And the root cause analysis is very valuable because you can prevent future cases of happening and repeating the same what has happened now, right? So this is pretty much the main idea. Now, the question, obviously, probably you're asking yourselves as well, so why are you describing it as so challenging? And this is challenging. I mean, we have seen it in many customers. They are struggling, and there's many reasons for that, but we try to summarize two, and we looked to those like from two different directions. One is the data available out there, right? So normally in the manufacturing, you have these big two big worlds, right? You have the shop floor world where all your devices and equipment are. Think about, some databases and historians storing all your sensor values. Think about the SCADAs and the DCSs, which are actually controlling your equipment and your machines, and the PLCs. Think about the sensors and many, many more. So this is one world, really one world. When you think about the data coming from this world, it is quite interesting, right? It is like a zoo. It's very diverse. You have everything. It's unstructured normally. Sometimes it's streaming. Sometimes it's sitting in some database. It's in raw format. All kinds of formats you can think of. And the worst part, of course, is it's distributed in many different places. And then you have the ERP and the business world on the top floor. It's what we call enterprise resource planning, right? You have everything there. You have your supply chain, sales. You have information about the finance, about your orders, about where you buy your products and raw materials. This data is more like enterprise friendly, right? Because it normally is structured way. It's a table, it's a transactional sometimes. It is in an aggregated format most of the times because you don't need it on a very granular level. And it is normally distributed, of course, also in different applications, right? If, for example, in S4 of SAP, and then some digital supply chain parts, stuff like that. So you can see two worlds, very different properties. And then let's look a little bit into personas involved as well. Again, on these two levels. On the shop floor, obviously, we have everyone related to operations, right? You have the operator who is actually operating the machines. You have the maintenance personnel, engineers and technicians who are servicing the machines, maintaining them, and the whole equipment and assets, not only the machines. And then you have also some production responsible guys. On the other hand, there's this other world of enterprise planning, which is on the top floor. And we have here people actually planning the whole production, and the managers, and oftentimes also the IT experts who are trying to link these two things together. So I forgot to mention before that everything which comes from shop floor in terms of data is called operational technology or OT data. And what we have on top is obviously the IT data in this case. So this was a short intro. Now I want to go to the use case, the predictive quality use case we really have seen with this industrial adhesive manufacturer customer. So what we found out there and how they approached us is, and I'm just repeating is because we have seen it in many other customers. It's always the same, right? So it's lack of centralized view. Oftentimes it's very hard to have one view where you see your IT and your OT data. You see your assets, you see the health of those, you see the sensors corresponding to those, everything together. Very difficult, very challenging. So you don't have this centralized view, and it's hard to actually understand what's happening in your process oftentimes. But if you have it, and this is why they came to us, you can better understand what is driving the quality, how you can prevent those things, and obviously also predict in the best case. And what we did here, we tried to do this unification of OT and IT data, as I mentioned before, but not forgetting also the business users, as also Hernan was showing us before. We created also dashboards so they can actually track and see the current status of the whole process, if we can call it process. We developed the machine learning models and trained them on the historical data, as you see in a bit. And then we fed those, very important point, we fed those back into the system, because this is where the real value comes. What if I know that the quality is going down? How can I, for example, trigger notifications for my, I don't know, service technicians to go and fix something on the machine, or actually even trigger our ordering process to get better quality material from my supplier. So all these things to close the loop is very important to have an optimized process. And of course, empower these two worlds to collaborate through this unification or convergence of these two data sources. Just to know what you will see in a second, very roughly, we included the recipe information in this case, information from the quality management system, or the quality check system actually, for spec and out of spec batches of this produced adhesive in the past, and a lot of sensor values, right? We had like 300 sensor values, sometimes less than a second data, a lot of data. I want to make one small point here, because I'm sure you're asking yourself, and we get it a lot. If I have sensor values, can I actually not do the prediction only based on those? And that is true. I mean, if you could do that, you should. I don't think there's any need to go on top floor and combining some stuff. But most of the cases, the sensors only will give you the current situation in most cases, and then you are missing the root causes why this is happening, because oftentimes these lie in other type of information. Those lie, for example, in your business data, or in your recipes, or in your supplier stuff you don't have on the shop floor. And that's where it becomes interesting, because yes, if it's only sensor data, you should do it, and it can be done pretty much by any software. But when you combine those data and merge these two worlds, it becomes more interesting, because you can start predicting, you can start digging the root causes. You can also, as we saw before, also do what if scenarios. You can simulate the influence of the process parameters. What if I don't know, get stuff, raw material from this producer? How does it influence my probability for a drop in the quality, right? And of course, at the end, you will have something. You go to the, this will pave the way to the automated and optimal production. And as you can see, this is exactly where the more business value lies, because this has the predictive, preventive action. And yes, and then as you can see also, this has a huge width of requirements, from analytics to integration, to data management, to connectivity to different systems. Okay, so this I wanted just to make sure that everybody knows what is the importance of this data convergence. In the case of the predictive quality case, which Andreas is going to show you in just 2 slides, just bear with me. I want to show you the high-level architecture. Don't want to spend so much time here on the product names themselves, but I wanted to say we had the shop floor data with the sensors, had the recipes and the process data on the supplier information on top. We combined those together in the business technology platform. And then there we did the model, which we'll talk about in a second. And as I said before, please keep in mind, after the model was done, we used the integration to bring it back to things like S4 to do the retrigger new orders if needed, or to some digital supply chain information or asset health software to actually trigger fixing some problems, for example, in some of the assets. Real quick, why we did it in SAP HANA, I think Hernan mentioned it before. I just wanted to make one point that we used the predictive analysis library. It's very important because this contains all the algorithms pretty much which are fancy and out there. There's actually quite a lot of those. I would just put some of them this is 2021, end of 2021, by the way. But this library, the objective of SAP was to bring the open source world, implement it in a library and bring it where in the database, where the data is, not the other way around, to avoid this data movement, not to have to move data out of the system, but rather bring algorithms where the data is. This is very crucial and very, very important, as you will see and as we saw before. I'll skip this slide. I'll leave it for your reference later on, just to know that there is a HANA, Python and R interface, so you don't need to, for example, use SQL to do this. You can stick to your favorite language of choice to do the predictions. With that, I want to hand it over to Andreas, who will take you now through the demo and talk a little bit what we actually did there in this customer.
Super. Thanks very much, Stoyan. So I'm just taking over the screen. And you should be seeing myself now. You should be seeing my desktop. And I hope you can hear me well. So what I'd like to do now is to go deeper into the case now that Stoyan explained, the predictive quality for a chemicals manufacturer. And I will show two things what we implemented here. First, the business user, where a person was benefiting from predictions that were being created, but also the data scientist point of view, and also the IT angle, where in which environment the system was actually configured, where the machine learning model was being trained. And this implementation we did for that chemical company is really for, let's call it a mid-market company. It's a company that's producing glue. The company name is not a household name, I would say. And it's really something that is relevant, I would say, for companies of all sizes. So it's not just for the big, huge enterprises, but no matter what size of a company, machine learning is, of course, it's just there. That has become a necessity almost. But the situation that company was in, just to say a few words about that, to really nail down why they had to work differently, why they felt it was time for a change, because manufacturing quality, of course, is of such utmost importance, and there's so many reasons why companies, of course, already optimize on these topics. So, of course, it's not a new topic to improve manufacturing quality or to use mathematical concepts to improve and analyze manufacturing quality, but they felt that there was a big lack in their aim of what they wanted to achieve, and that we will see in this display here, where they were facing a compromise. They had to do one or the other. Both of them had their advantages, but it was a big compromise. Where let's start maybe on the right-hand side, the orange button, where we have high processing speed, but only sort of partial data. And this means looking at one sensor in the manufacturing process, maybe a thermometer in the chemical reactor, where in real time, you do know the temperature, you can analyze, you can understand what's happening. Maybe you can do some statistics where this one single time series is deviating to, but it's missing that bigger context that Stoyan explained. So which product is really being produced in this sensor? Who's manning the machine? What raw material is in the machine? All that would not be available here. So you have that ability, yes, you can do it real time, you can do it fast, but you don't have the big picture. And the other sort of a way of working, they had the blue dot here, where the data was much, much more complete, where they had to go through a manual process to bring all data together, understand what happened in the past, to bring all that additional logic and context together to do a bigger, more holistic analysis. So there the data was complete, but of course, it takes a lot of time, easily takes weeks until the data is actually in one place and then until the analysis has been completed. But they were aiming for that real-time prediction, real-time analysis, that while the manufacturing plant is running, in real time to understand what is happening while a batch is being produced, to assess whether things are going well, whether there's a high risk that this current batch might be of bad quality. And very often, especially in the chemical industry, it is possible to steer against that trend of a negative quality while it's still happening. You can intervene, you can interact with the machine, you can change the process, aiming that eventually the batch that is currently produced will end up as being of good quality, or in spec, it is very often called. And this combination to do it in real time, holistic, with all data available, this we implemented with that Sap Business Technology platform. And how that looks like now for the business user, here coming up for the plant manager. And we see an analytical dashboard. The tool name came already up once. It's called Sap Analytics Cloud, where now that plant manager, who obviously is not a data scientist, but that plant manager needs to have an instant understanding of what is happening. There are different views that we will sort of go through. First, we'll look at what happened in the past, how many batches were in good quality or of bad quality. So trying to get that historic understanding. Where now, so you can look at the individual batches, but on that view, you see now what is happening at the moment. The first line shows the current batch currently in production. We don't know the quality just yet, so that that is empty. Previous batches likely were in spec, meaning of good quality. But now going more into what is happening now, here's an alerting system involved where we already see that the cutter blades don't seem to be sharp enough anymore. Such an alert can be manual rule, or it can be triggered through machine learning, making machine learning really actionable. And on that screen, we see exactly for the current spec, the current batch, what is happening. And every, in this case, 5 minutes, we get a new prediction. And currently it is predicting out of spec. So it's looking like something is going badly. No, you have to intervene while the batch is produced, while you still have a chance to do so. And here in this chart, you can understand the reason, the driver for why it thinks it might be out of spec. And we see that the particle size deviation of the raw material is a big problem, but also the shear rate relating back to the cutter that was an issue earlier. So here you can already trigger, trying to improve quality while things are happening. But on that view, what we see here now, that's an understanding of the machine learning model itself. So this is more general. It's not just looking now at the real-time aspect of what is happening, but this is a very business user-friendly view to explain the logic of the model, and it explains what could be potential drivers of bad quality. Now, I won't go into too much detail really, but you see the 7 or 8 bars on top. These are the different fields of predictors that the model chose, where it understood that these pieces of information have an impact on good or out of spec quality. And for example, the third bar here is referring to the name of the supplier of raw material that is being produced. So here clearly, depending on which supplier is used for the raw material, it tends to be of better or worse quality. And the chart below gives an indication of what is leading for this specific information. So which information tends to be rather good quality and which one tends to be rather bad quality. So very, very informative, real time, but also that holistic understanding presented in the business user point of view. But now looking at IT and the data scientists, so people who actually set that up. And here now in this interface, we start by a pipeline, which is pulling the data together in real time. Here, reading data from the sensor, so-called historian, where in here we pull in data just for the sake of a demo every 5 seconds. So every 5 seconds, a new data point is brought in. In reality, even in manufacturing, 5 seconds is extremely fast, but it could even be faster in reality. Maybe it's more 5-minute intervals where you see the data coming in, and then the sensor data is enriched with that context here coming from an SAP system, the business data, such as the supplier of a product. And here we see finally the predictions now coming in every 5 seconds. So the pipeline is running permanently. And you see how the probability sort of slightly changes based on the latest information. And the machine learning model itself was created by a data scientist working here with Python. So you mentioned that we have a sort of Python and R interfaces to trigger the machine learning algorithms, to train the model, to create predictions. The notebooks, of course, not very familiar and popular with data scientists, not a technology that we developed or we integrated, so that data scientists can stay in the environment that they're most familiar with, but still benefit from the underlying platform that brings the data together, that prepares the data. And it's not just bringing data together, of course, it is often the aggregation. If we go back to the sensor data, the temperature, what is the current temperature? Of course, that is important, but also how has the temperature changed over time? What was it like an hour ago? Has it increased? Has it decreased? So all this capability that has to be available, not just on the data scientist's laptop, but as part of the ongoing operations. This can be developed here in that interface and then deployed through the graphical pipeline that we saw earlier. And with that, we're already coming to the takeaways now for this presentation, the biggest points that we thought we wanted to summarize again towards the end. So looking at the democratization of machine learning, that machine learning comes in so many different flavors, not just the different algorithms and the different kinds of machine learning, but really the different users that benefit from machine learning or actually create machine learning have very, very different requirements. And so based on the experience and the role and the profile of the user, it's absolutely crucial to bring machine learning into the right format, that it is usable for the different kinds of users. It's also important not to underestimate the complex data landscapes, because in reality, data is never in a perfect place that you could immediately start your machine learning. Of course, it has to be first identified, it has to be explored, the data has to be often improved, it has to be prepared, and then you can start working with actual algorithms, trying to find a model that provides value then to your business processes. And that integration into the business processes, into business, of course, is also then the crucial element, because having a fantastic machine learning model that exists on somebody's laptop but is never used, doesn't have any impact at all. Obviously, it has no impact, doesn't provide any value. So the creation of machine learning that doesn't end when the machine learning model is created. In a way, it never ends because the business processes keep continuing, and you have to bring machine learning, data science, artificial intelligence into these processes, which also means that it has to be monitored. You need a platform underlying it, something that re-triggers the models, something that provides visibility in what is happening, something that keeps the whole process, of course, in check. And you don't want a model that was trained 2 years ago on data that is not relevant anymore in a current operational process. And then we hope we provide a lot of value in this area with that business technology platform that we spoke about here, so that coming back to the Red Queen, that you're not just running on the spot, not really, nothing really changes, but saying that, running on the spot also means, well, you have to run, because if you don't run, you're left behind. So running is important. You have to do it, but at the end, you want to differentiate, and hopefully we gave some ideas on how that can be done, and how SAP is, of course, somebody where we hope we can provide a lot of value. With that, we are thanking you for your participation, and I believe we have a little bit of time for questions.
Yes, thank you. Thank you so much to all the presenters for delivering such a complete and comprehensive masterclass. I do have a couple of questions. I'm gonna start with the one that I think it was triggered because of the first question. So we answered already that you can prepare the data in a solution called Data Warehouse Cloud, prepare the data, and then bring it outside to leverage another machine learning models or algorithms outside SAP. Now the question is, what about the other way around? So if you have the output of the machine learning from a hyperscaler, for example, how do you bring this output into the business process? As you were mentioning, Andreas, it's very important to have value or impact while leveraging machine learning. If you don't have the impact or value for business, maybe it doesn't make sense. So how do you bring this output from the outside into the business process? That can be done.
Mm-hmm. Yeah, no, absolutely. So the Data Warehouse Cloud has a lot of connectors to data that lies outside an SAP system. So data can be made available, and we can pull in the data whenever it is required. Or it could be sort of an ongoing process where the data is persisted in the Data Warehouse Cloud and immediately available, for example, for machine learning algorithms.
Okay, perfect. And then the second question, I think it's much simpler. So how long did it take to finish this customer use case on the predictive quality?
So the actual sort of project duration sometimes is quite hard to quantify, because it's not people working full time on such a project very often, but it's something like very often it's a side project, often for the customer side, but also on our end almost. A lot of time sort of passed because the customer then had to literally search for the data to collect data. One example is a manufacturing batch where not immediately it was clear whether it's in spec or out of spec. And then literally the customer had to start researching who knows whether this batch that was unsure at the end was it deemed to be of good or bad quality. But the actual work of implementing this, I would say we can quantify in weeks. The actual project period was longer, but often with idle time in between.
Okay, so as I understood, like preparing all the data and everything that was needed before getting this data handled, it was just in a matter of weeks, the actual data work. Okay, that's nice. So no more questions. Let me just double check. Nope. Thank you very much to everyone attending to this masterclass. Thanks to the presenters. Thanks to the audience. Just to remind you that a survey is going to pop up once we finish. Please take the time to answer, because this way we can improve the way we deliver these masterclasses. Thank you so much.
All right. Thank you. Bye.